Okay, so welcome everyone. Welcome to yet another interesting journey. So today we try something new. So today we'll look at complex numbers. Okay, so that's the topic for today, complex numbers. Okay, so today, without wasting much of time, today basically we want to look at this thing you call, there is nothing like at diploma level. There is nothing like you find a square root of a negative number then you say it can't. No. So now it's a little bit inappropriate for a diploma student to say, for example, we tell you what is the square root of -4. So from our basic mathematics, we'll say no, a negative number doesn't have a square root, but now it has. So a negative, we just represent it as a j, and then the square root of a 4 is what? 2. So that's what we want to discuss. If you have a square root of a negative number, so that negative is represented as j. Okay, so having said that, I think before we dive deeper, let's try to solve this one here, problem 1 first of all. Let's try to solve problem 1, okay? So for problem 1, it's quite simple. Most of us have solved this problem before. X squared plus 4 equal to 0. Okay, so there are a lot of methods you can solve this problem with. You can use the formula method, -b plus or minus square root of b squared minus 4ac over 2a. Okay, so from here, so you write this equation in this form. So you see a is a coefficient of x squared. So the number in front of x squared is a. So in this problem, a is what? 1. We know, we don't write 1, just write. Then b. Then b is a coefficient of x. So x, we don't have x here, so b is what? 0. Okay? Then c is an independent variable at the end. So you get with a sign. So if it was negative here, we would have said -4, but since it's positive, we just write 4. Okay? Yeah, so now if we put these values in our equation, we have x equals to -0, so no need of writing -0, it will be just 0. Okay? So just say plus or minus b is what? Is 0. Okay? Minus, so we have 4 multiplied by a is 1, multiplied by c is what? C is 4. Okay? Over 2, what is a? 1. Okay. So x equal to, so 0, you can write it for completeness sake, but it doesn't really matter. Okay? Plus or minus. So here, 0, it will be 0. 0 squared is 0, minus 4 multiplied by 1 multiplied by 4, it will be 16. Okay? Over 2. So it will be x equal to plus or minus, okay, plus or minus. So 0 minus 16, it will be just -16 over 2. Okay, so great. So when you reach here, we know x has 2 variables. One, we have a positive -16 over 2, or x can take up positive or negative square root of 16 over 2. These are the two answers for, sorry, this is negative, okay, negative. These are the two possible answers for x. So x equal to, what's the square root of negative 16? I've said there is nothing like it can't. So a negative, when you're taking a square of a negative, you use j. Okay? So what's the square root of 16? 4 over 2. Or, so this is negative. So positive, no need even of writing it, okay? So by the negative, you write to write it. Then here, same applies, negative 16, so it will be j 4 over 2. Square root of 16 is 4. But since it's a negative, we take it out with a j. Okay? So x, 2 into 4 is what? So it will be 2. So this is 2, or negative 2. Yeah, so these are your possible answers for x. Okay, so this is what complex numbers are all about. When you find you are getting the square root of a negative number, you just include, you just put what? At the end, I mean at the beginning, you introduce a j component. So a j represents complex. Okay, so let's come to this. Problem 3. Okay, so problem 3, you just have to write some identities. So one important identity when you're dealing with in complex numbers. So one of the most important identity is j squared is equals to negative 1. So you need to know this one. This is the most powerful identity when you're multiplying or you're doing anything with indices. J squared is equals to what? 1. So whatever number you've been given, you just write it, you just express it with a j squared. Yeah. So what I mean is, let's take for example, let's answer problem 3. So you have part A, j to the power 3. They're saying you evaluate. So this, you just take out the j squared, okay? J squared part. Meaning it will be j squared part, meaning it will be what? Here, what will be the power? So you have j, because this is the same as you are adding the power. You're multiplying these two. So this has a power 1 and this has a power 2. So 2 plus 1 is 3. Okay? So what does this, how do you solve now? Okay, so first of all, you introduce, you have to rewrite this expression so that you have a j. You have a j here. You have a j squared, so that you get negative 1. So if you write j squared, what will be its power here? So if you write j here, what will be its power? Okay, so like I was saying, so this is same as multiplying it by a j, because 2 plus 1, it will be power 3. Okay, so now we know j squared is negative 1, so this is negative 1 by j. So meaning your answer is negative j. Okay, very simple and straightforward. Okay, so you just have to find a way of expressing it where you have a j power 2 on its own. Okay, so let's say B now. Let's try to answer B, those who didn't understand. So we have j to the power 4. Okay, so this one is j squared multiplied by j squared, because 2 plus 2, it will be 4. So j squared is what? Negative 1 multiplied by negative 1. So this is just 1. Okay, C, what's C? C is j to the power 23. So you have j to the power 23. Okay, yeah, so for this one you write j squared. Okay, so j squared, then you can have a power here. How do you get the power? Okay, so you have a j. How many is remaining? So 22, we have 23 minus 2, that is about 21. Okay, yeah, 21. Okay, so then you multiply this by j. Let's get the powers now. So 2 plus this, it will be 3, meaning we have a power 20 here. Okay, yeah, 2 to the power 20. You can do j multiplied by j squared multiplied by j squared multiplied by j squared multiplied by j squared 20 times, but there is no need. You just express it as an index. Okay, so you have -1 to the power 20. So 2 multiplied by 20 to be what? No, it doesn't have to be 20 here, sorry. This is not 20, so it has to be, this power has to be 10. 10, let's say 10. Then meaning here it will be, okay, this has to be 11. Okay, sorry. So it has to be 11. Because if you multiply 11 by 2, it will be 22 plus 1. It will be what? 23. You get a total here. Okay? So sorry for this one. No, can't have 20. Because 20 multiplied by 2, it will be 40. Okay? So power 11 multiplied by j. Okay? So this just some mathematical tricks. A negative number power even power. Even power, these are numbers like 2, like 0, 2, 4, 6, 8, 10, like that. If the power is even, the answer is always positive. If the power is odd, so odd numbers, so odd numbers or prime numbers, any numbers rather than even numbers, you know that the power will be negative. So you just have to check. You just have to know even numbers. These numbers divisible by 2 without giving any remainder. So if you divide 0 by 2, you see, is what? 0 divided by 2. 0 without any remainder. 2 divided by 2 is 1 without any remainder. Okay? So if the power is not even number, you know that it will be negative. So here you have -1 by j. So your answer is negative j. Okay. So let's go to D. D is -4 over j to the power 9. Okay, so this is j power 9. So we'll do the same thing we've done for the area example. So we write -4 divided by, so let's say j squared. Okay, you always have to express j squared because we want a -1. So how can we get the 8? So if we say power 4 here, multiply it by j, what are we going to have here? So 2 by 4, 8. Okay, plus 1, this one 9. Okay, no, so we are on the right track. So say -4 over, so this will be -1 to the power 4 multiplied by j. Okay, so this power is even number. 4 is an even number, so this is just 1. So you have -4 over j. Yeah, just like this. You finished just like this. -4 over j. This is your answer. Very simple and straightforward. So just know a sorry. Do I like writing I? Okay. So j squared is equals to -1. This is what you have to know. Then you can express any number. You can express any number. So you just have to have a j to the power 2. Here you just need to have one j. So try to find a number which you can multiply to give you the form closer to the one you want. So let's try for just playing j to the power 11. Okay, let's try this one. Let's say this is our e, j to the power 11. So first you have a j squared multiplied by a j. So already we have 3 j's here. So what do we write here? 2 to the power 5. So here, you know, we can put 5. Because 2 by 5, it will be 10 plus 1, 11. Okay? Just like that, simple. So it will be -1 to the power 5 multiplied by j. Okay? So negative, this is not even, so this is -1 multiplied by j. So you have -j as your answer. Simple. Okay, so that's about this part 1 and problem 3. So now we go to the most interesting thing. We go to problem 10. It's quite interesting. So problem 10 is about expressing in polar form. So polar, first of all, let's try to understand this, the way we represent. So you have the R here, then we have an angle theta. So this is a imaginary. This one is imaginary. Imaginary axis. So this is the j component because the j is imaginary. Okay? Then this is the real axis. Real axis. So same applies. It's the same Cartesian vector. So the same ones we write, this is x, this is y. But now our y is imaginary, and then this is our real axis. Then we have a vector here with a magnitude r. Then this vector makes an angle theta with the positive x. Okay, so this is what we have to know about complex numbers. When you want to represent it on the as a polar form, what we mean is represent it with a magnitude r in this angle. Okay, so if you have 4 plus j4, so meaning what it means is your real number is this one. This is your imaginary. The one with the j is imaginary. So meaning this is 4. Then here 4j. This is what it means. So if we have 4 minus j4, okay, for this one, you know the real part is 4, but the imaginary part is -4. So you have something like this, r, then you have the angle theta. So, okay, so let's just say this. Okay, you got it now. Yeah, so this is how you represent it. Yeah, wrapped everything. Okay, so you have something like this. Then you have this vector. Okay, so real part, you need to know real part, imaginary. So the one with a j is imaginary. So it's an imaginary part. So each complex number So a complex number, if they ask you what is a complex number, so I wanted us to reach here first before we define a complex number. So it is a number which has the real and the imaginary component. So it has two components, the real component and the imaginary component. So at times they use the notation A to represent the real part, then B to represent the imaginary part. So if we express a number in this form, we just mean A is real and B is imaginary. So don't be confused. Okay? So we just have a real and imaginary part. So now, to answer the questions, let's start with the first one. So the first one is A. So 3 plus J 4. Okay? So this is our real part. Real. This is our imaginary part. Okay? We need to identify first of all which one is our imaginary, which one is our real part. Okay? Next. So in polar form, we need to change this to become R at an angle theta. So this is in polar. R at an angle theta. That's what it means if they say explicit in polar form. This is the polar form. R angle theta. So first of all, we have to draw this to show it on our axis. So we have the real part, real, imaginary. So we have real is what? 3. Imaginary is J4. So we have something like this. This is our R. So this is angle theta. Okay? So we need this R and the angle theta. So if for those who don't remember, or for those guys who remember nicely their grade 12 work, you did something in grade 12 which looks like this. You had this, a right angle triangle. Okay? So this right angle triangle, it has the sides hypotenuse. Okay? Then this is opposite to the hypotenuse. Then this is the adjacent. Okay? You remember these things. Then from here, you remember this, the SOHCAHTOA, which we only use to a right angle triangle. A right angled what? Triangle. Okay? So this, we know how, then we also remember our Pythagoras theorem. If this is A, this is B, this is C. If we want to find A, we know A squared equals to B squared plus C squared. Yeah, we remember this Pythagoras theorem. So this is SOHCAHTOA. So sine is opposite divided by, so sine SA sine theta equals to O, opposite. H is hypotenuse, so it's opposite over hypotenuse. This is C is cosine. Cosine, let's say cosine X or theta. Cosine is adjacent, so A adjacent over H hypotenuse. Okay, then we have the last part, TOA. So this is tangent, tan. Let's say tan theta equals to opposite. So it's opposite over adjacent. Okay, so you need to remember this before you come here. Okay, so if you see here, our triangle is like this. This is our triangle. So we have this angle theta which we want. We know this distance from here to here is this one. So we know this distance here. We know the number here. We know this distance. We also know this distance here. Okay, so we can get the angle very easy. Okay, because the angle, so this angle, if you see tan theta, we can use tan because we have the opposite. This angle, its opposite is this side. So we can't use cos. Cos is adjacent over hypotenuse. Hypotenuse, we don't know r. We haven't calculated r already. But if we want, we can start with r, then use any of these. It doesn't matter. It's not a problem. Okay? Yeah, so if you see this angle, its opposite is this part, which is just a distance from here to here, which is just this 4. So the I is just to show you that this is an imaginary axis. Okay? But if we want to use a number here, we just get the number 4. Then adjacent is 3. So if you say tan theta equals to, what is the opposite? Opposite is this side. So it's this distance, 4 over 3. Okay? Then theta equals to, we just take tan inverse on both sides. So tan inverse of 4 over 3. This is how you solve for an angle. So theta equals to, do I have my calculator? It's my calculator. Okay, let me just punch quickly. Okay, so we know tan inverse of 4 over 3 is 53 degrees. So now, how do we find r? R is the hypotenuse. So you use that formula. So r is the square of this side and this side. So it's just 3 square plus 4 square plus this one is also square. So r square equals to 3 square is 9 plus 4 square is 16. Okay? So r square equals to, this it will be 25. Square root, square root. So r equals to 5. So now your answer in polar form is, so you write first. Write the question 3 plus J4 in polar form is 5 at an angle 53.13 degrees. This is how you write. So you do the same for all the questions. Okay? So even without plotting, now you know what is really happening here. So you have B, you have negative 3 plus J4. Okay? So you know R, we can quickly get R squared equals to, you just square each number here. So you have negative 3 squared plus 4 squared. So which is 9. 3 squared is 9 plus 16. So this plus this, it will be 25. So R squared equals to 25. You take a square root, R equal to 5. Okay? Then how do you get the tan? Now we take theta, you know tan. So tan is equals to what? So tan theta, so I said tan theta, that angle is equals to what? the imaginary part. So if you want to remember imaginary, over real. Okay? If you want to remember, so tan theta equals to, imaginary part is what? 4. Over real part, negative 3. Okay? So you quickly punch. So for this is tan inverse of 4 over negative 3. So what's tan inverse of negative 3? So moment I punch. So tan inverse of negative 4 over 3. So you're getting so they didn't say we show on the polar coordinate, so meaning your answer negative 3 plus J4 equals to R. R is what? R we've already found is 5. Angle negative 53.13 degrees. So unless they ask to show on the polar coordinate, I was just showing you where these are coming from. So this is just for your understanding. If you're just solving, and you don't have time, you just have to stick to what the question requires. That was for understanding purposes. So C, negative 3, negative J4. Okay? So we just calculate R. R is a square of each. So you have negative 3 plus negative 4. Okay, so you have 9 plus 16, which is 25. Then you take, so this is R squared, sorry. So R squared equals to 25. Let's take a square root, take a square root. R equal to 5. Okay, next, theta. How do you get theta? Theta. Okay, so you write tan theta. Just wanted to write directly. Imaginary over real. Okay, so imaginary is what? Negative 4. Real is what? Negative 3. Okay, so this will have positive, mean theta equals to tan inverse of negative, tan inverse of 4 over 3. This one I think we've already found is 3.1 degrees. Okay, so they will be just, what to vary with these questions is its position on the coordinate. Okay, so its position will change. So we'll show them, okay, on the polar coordinate for those guys who want to understand better. Okay, so negative 3, but the question doesn't require us to do that. So just for completeness sake, you have 53.13 degrees. Okay, so this is your answer. This is in a polar coordinate. This is what they want. Okay, let's go to part D. So part D is 3 minus J4. Okay, so first you get R squared equals to 3 squared plus negative 4 squared, which is 9 plus 16, which is 25. Okay, and you take a square root of R, take a square root of 25. R equals to 5. It's not always, but it's just this question. They might give you whatever number they feel they can give you. Then now, tan theta equals to imaginary negative 4 over real 3. So we have already found this part, negative 3 over 1. Okay, so meaning 3 minus J4 is same as 5 at an angle negative 5, 3.1 Okay, so now I want us to represent these. We try to show them on the polar coordinate, even if we are not requested to do that. So let's do that. So for part 1, let's draw. We can draw a straight line. Okay. So let's say this is our imaginary, and our imaginary axis. This is imaginary. This continuous. This is our real. So real, imaginary. Okay, so 3 is real, so we have 3. Let's write 3 here. Then our imaginary is, for part A, is 4. Okay, so we have something like this. So we have this vector. This angle we found as 53.13 degrees and R 5. Okay, this is what it means. Then let's come to B. Let's come to B. So B, the angle is what? What is the angle for B? We have calculated B as negative. Okay, so let's first, B we have negative 3. So our real part is negative 3. So negative 3. Then our imaginary part 4. Okay, so it's just here. So it will be just something like this. Okay. Oh, perfect. This one I've drawn it nicely. Then we have this angle theta. Okay. So this is how it will appear. So this is 5. And the angle is what? The angle for B is negative 53. So negative 53, meaning if you see positive, we move from this axis going like this. We move like this. Or there are 2 ways of moving. Let's say this is what? What kind of movement is this? This is clockwise. Okay? Then there is also this one, which is anti-clockwise. Is it? Wait. How does the clock move? A clock moves like this. Okay, so this is clockwise. Okay? Clockwise. Then this is anti-clockwise. Or counterclockwise, anti-clockwise. Okay. So the clock moves like this. Yeah. I think so. Yeah. This is how the clock moves. This is anti-clockwise. Okay. So the angles are just there to show you the direction that you're moving in a clockwise or anti-clockwise. Okay? So if you see, if you're moving from a positive x direction, this is positive x, we are moving like this. Okay? So this is positive, but here we are moving like this. No wonder it's negative. Okay? So this angle so the angle here is we write 53.13. We know it's negative because the direction is from the negative x-axis. okay, because it's negative. So if it's negative, meaning the direction has changed. Positive, positive, anti-clockwise. Then negative, counterclockwise. Okay, great. So let's go to C. C, how do we represent C? C is negative 3, real part. This one, real part negative 3. Then the imaginary also negative 4. So we have something like this. So this has an, okay, it has an angle here. So this angle is positive. So this angle is positive. Okay. I think so. Yeah. See the angle is 53, positive 53. Okay. So which direction does this vector moves? So the r is 5. The vector, how does the vector move? Is it clockwise or anti-clockwise? So we state 53.13 degrees. So how does the vector move? This is a positive one, meaning it's anti-clockwise like this. Okay? So yeah, that's how it is. It's just like this. It's moving in anti-clockwise direction. Okay? Then this one, real part 3, then the imaginary part negative 4, so it will be something like this. This is the angle, 53.15 degrees. Okay. Yeah, so this is how they will appear on this the magnitude of r is 5. So this is how these vectors will appear. So the negative of these angles, they just tell you the direction of the vector. Yeah, the direction of the vector, whether it's counterclockwise or anti-clockwise from the positive x direction. Okay, so that's the physical meaning of the angle, the sign. The sign of the angles. The sign of the angle, it just gives you the direction of how that vector is, or how is that vector rotating with respect to the positive, in this case positive real axis. Okay, so in here for today. Okay, so continue following my page, invite more people. Okay, so where you need clarity, you can always ask. You can write me emails. Yeah, so thank you so much for my new followers. Yeah, let's learn together. So a quick tip for today. I'm writing I again, sorry. So j squared equals to negative 1. Okay, then also we've talked about SOHCAHTOA. So this is sine equals opposite over hypotenuse, cosine equals adjacent of hypotenuse, tan equals opposite over adjacent. We've also revised Pythagoras theorem, where if we want to calculate the hypotenuse, you just add opposite plus adjacent. Okay, then if you want to find any of these, you just make O subject or A subject. Simple as that. Okay, so thank you and have a blessed night.